Forget Mars. The best place to find alien life is not a planet at all. It is a frozen moon you have probably never heard of. Liquid water, heat, every ingredient life needs, all of it, hidden under the ice. So why are the smartest scientists on Earth betting on this tiny world? If you had to bet everything you own on one single place to find alien life, you would probably say Mars. You would be wrong. The best bet in the entire solar system is not a planet at all. It is a frozen moon smaller than the state of Arizona, hiding a secret that should not exist. And the strangest part? It does not even make us dig for the answer. It throws its ocean out into space and practically hands us the sample. Out here, almost 1 billion miles from the sun, on a world locked in permanent deep freeze, scientists have found something they once thought was impossible. Everything life needs, all in one place. So why do some of the smartest people on Earth now believe this tiny moon, Enceladus, might be the single best place to search for life beyond our own world? Let us walk through the case. For most of human history, our search for life followed one simple rule: find the sunlight. Life on Earth runs on the sun, so we assumed alien life would too. We drew an imaginary band around every star and called it the habitable zone, the cozy region where a planet is just warm enough for liquid water. Anything outside that band was written off as a frozen wasteland. Enceladus sits far, far outside it. But then we found something strange in our own oceans, deep on the sea floor. In total darkness, miles below where any sunlight can reach. There are cracks in the rock, spewing hot, mineral-rich water. We call them hydrothermal vents, and clustered around them, with no sunlight at all, are thriving communities of living things, entire ecosystems, powered not by the sun, but by heat and chemistry rising from the planet itself. That discovery rewrote the rules. If life on Earth can survive in cold, black water with no sun, then maybe sunlight was never the point. Maybe all life truly needs is liquid water, a source of energy, the right chemistry, and enough time. And that completely changes where we should be looking. Suddenly, a frozen moon with a warm, hidden ocean is not a dead end at all. It might be exactly where we should look first. So scientists made themselves a checklist. NASA defines life as a self-sustaining chemical system capable of evolving over time. Strip away the technical language, and finding a place that could support life comes down to 4 boxes you need to tick: liquid water, energy, the right chemical ingredients, and time. Let us go through them one by one and see how Enceladus scores. Box 1, liquid water. We already know Enceladus passes this test, and it passes it spectacularly. Thanks to the Cassini mission, we are now confident there is not just a puddle, but a global ocean of liquid salt water wrapped around the moon's rocky core, sealed beneath the ice. By tracking the way the moon wobbles as it spins, scientists confirmed this sea stretches from pole to pole. That is a staggering amount of water hidden inside a tiny world. So box 1 is checked. But water alone is just a cold bath. What about energy? This is box 2, and it is where Enceladus really shines. Remember, the sun out here is useless, but the moon does not need it. Saturn's gravity flexes and squeezes Enceladus on every orbit, and that constant kneading generates heat deep inside. Cassini found direct proof of this. In the spray coming off the moon, it detected tiny grains of silica, a mineral that can only form when liquid water and hot rock react together at temperatures above 90 degrees Celsius. Think about what that tells us. For those grains to exist, there must be hot water meeting rock at the bottom of the ocean. In other words, Enceladus almost certainly has hydrothermal vents on its seafloor, the very same kind of vents that host life in the dark on Earth. A cold moon, with a hidden ocean, warmed from below by chemistry in the rock. Box 2, energy, is checked. Now for the part that really matters. The ingredients. Every living thing we know is built from a small set of elements. Scientists sum them up with one word, CHNOPS, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These 6 are the essential building blocks of life as we understand it. For years, the question hanging over Enceladus was simple. Does its ocean contain all 6? Or is it missing a piece? As Cassini sampled the plumes, the elements kept turning up, one after another. The water itself gave us hydrogen and oxygen. The probe found carbon and nitrogen locked inside organic molecules. It even detected free hydrogen gas drifting in the spray, which on early Earth was a favorite fuel source for the very first microbes. One by one, the boxes filled in, but for a long time, one crucial element stayed missing. That element was phosphorus. It is rare, but it is non-negotiable. Phosphorus forms the backbone of DNA and powers the energy carriers inside every living cell. Without it, life as we know it simply cannot work. So scientists kept digging through Cassini's old data, hoping, and in 2022, they found it, phosphorus, hiding in the icy grains from Enceladus. With that final piece, the ocean had revealed all 6 elements of CHNOPS, the complete recipe. So that is water, energy, and ingredients all confirmed. But one box still remains, and it may be the hardest of all. Box 4 is time. A single warm, chemical-rich moment is not enough. On Earth, it took hundreds of millions of years for the first life to appear. So the question becomes, has Enceladus stayed warm long enough? Or did its ocean only melt recently, leaving no time for anything to begin? If the moon is just having a brief, lucky warm spell, the whole case falls apart. To answer that, scientists compared the heat pouring out of Enceladus to the heat its core should be generating from all that tidal flexing. And the numbers matched almost perfectly. That balance suggests the ocean is not a passing accident. It is stable. And it has likely been warm and wet for a very long stretch of time. Long enough, perhaps, for the slow chemistry of life to get started. With that, the final box is ticked. So step back and look at the full scorecard. Liquid water confirmed. Energy from hydrothermal vents confirmed. All 6 ingredients of life confirmed. A long, stable history very likely. There are not many places in the entire solar system that can claim even 2 of these. Enceladus appears to have all 4. But there is one more reason it might beat every other candidate, and it has nothing to do with the ocean itself. Consider the competition. Mars is a dry, radiation-blasted desert where any water vanished long ago. Jupiter's moon, Europa, likely has a deep ocean too, but it is buried under many kilometers of solid ice with no easy way in. To check either one, we would have to land, drill, and dig for years. Enceladus does something none of them do. It takes its ocean and fires it straight up into space, where any passing spacecraft can simply fly through and catch it. This is the part scientists can hardly believe. Nowhere else in the solar system can you sample an alien ocean without ever touching the surface. As one researcher put it, the universe is delivering the sample right to us. We do not need to break through the ice. We just need to fly through the spray and read what is inside. For a place that might hold life, that is an almost unfair advantage. It is why some of the leading scientists who study these worlds have started using bold words. One called Enceladus the Holy Grail in the search for life. Another said that for anyone hunting for life beyond Earth, finding these geysers was like winning every championship at once. A tiny moon nobody used to talk about has quietly become one of the most important destinations in all of space exploration. And yet, having the perfect conditions for life is not the same as having life. A kitchen stocked with every ingredient does not mean a meal has been cooked. Enceladus has the water, the warmth, the chemistry, and the time. But somewhere in that black, hidden ocean, did those ingredients ever actually come together into something alive? If they did, it would almost certainly be small. For the first 90% of Earth's history, all life here was microbial, invisible to the naked eye, so we are probably not imagining monsters in the deep, but microbes drifting in the dark, feeding on the warmth of the vents, never once seeing a star, tiny, patient, and utterly alien. It is a strange and beautiful thought that the best place to find our cosmic neighbors might not be a warm, sunlit world like our own, but a frozen moon quietly spraying its secrets into space. We have shown that everything life needs is there. The only question left is whether anything ever answered the call. And here's the thing. Cassini did not just measure the conditions. It flew straight through that spray and caught what was inside. What it found is a story for the next time. Keep looking up and stay curious.